Well, hi, here we go. Looking at 5 integral test problems that I had asked you to look at. The first one of these, we'll just get right started here. The first one of these was looking at the sum from n equals 1 to infinity of 1 over square root of n plus 5. And the integral that we would look at for this would look like the integral from 1 to infinity of 1 over square root of x plus 5 dx. There's the integral we're dealing with. If we write this in a better form, integral from 1 to infinity of x plus 5 to the negative half dx. And this is just a power rule antiderivative. And because it's just x with no coefficient, we can just treat this whole thing as u, and then du would just be dx. So if we just go right from there, this integral becomes x plus 5 to the negative half plus 1, which would be positive half, divided by a half, so times 2. There's our integral, and we're evaluating this from 1 to infinity. Technically, we're going to evaluate this from 1 to t, limit as t goes to infinity, but we should recognize that if we were to try substituting in the infinity, we'd get 2 infinity plus 5 to the half minus some value to, it looks like 6 to the half. Doesn't matter because this piece is off to infinity. So the integral diverges. Therefore, the sum diverges. And that's the nice thing about the integral test. If the integral diverges, so does the sum. If the integral converges, so does the sum. So let's go ahead and look at number 2, which I did change. We go back to, there we go, 2. Okay. So looking at number 2 here, I did make a little change. A few of you may have worked a problem that was a little bit different. This one now says integral I or n equals 1 to infinity of 1 over the cube root of n plus 5 quantity in there to the 7th power. That would be, if we switch to the integral to check the integral test, this is going to be an n plus 5. Sorry about that. X plus 5, just to keep our notation straight, raised to the negative 7/3 dx. Again, this is just going to be a power rule like the last one, and the dx would be, or du here would be dx, so we don't really need to go through that. We end up with x plus 5 to the negative 7/3 plus 1, that's 3/3. So that's a new power of negative 4/3. So here's my negative 4/3 power. We're going to divide by negative 4/3. In other words, multiply by negative 3/4 and integrate this from 1 to infinity. I'm going to go ahead and, well, we'll put the infinity for the moment. This becomes the limit, we'll say it this way, as t approaches infinity, of negative 3/4 t plus 5 to the negative 4/3. And then minus, we just plug in the 1, so plus 3/4 6 to the negative 4/3. This is just some number. We're good with that. Because the value we get for the integral doesn't matter. What matters is there a value or is it undefined? When I come back here and take the limit as t approaches infinity, recognize this is to the negative power. So this first piece really is negative 3 over 4 t plus 5 to the 4/3, looking at the limit as t approaches infinity. And this piece then, with a t getting larger in the denominator, is going to produce this thing heading to 0. And 0 plus some value converges. Again, it doesn't matter what it converges to, but if the integral converges, the sum converges. And that takes care of the first 2 problems. And I'm going to split this video in half, sort of. We'll do these 2, and then I'll come back at some point and give you the solutions to 3, 4, and 5. See you then.